August 6th, 1945. A single plane flies high over Japan. Its name? The Enola Gay. It carries a single bomb. The first atomic bomb. The camera plane captured this footage. At 8:15 a.m., the bomb exploded with the force of 15 kilotons of TNT, annihilating the Japanese city of Hiroshima. The destruction was unparalleled. The bomb worked by splitting uranium into small particles, but it wasn't long until the opposite process was discovered: fusion.
Both turn matter into energy using the most famous equation in all of science, E equals mc squared. The equation tells us that matter can turn into energy, and when it does, it gets multiplied by the speed of light squared, a very big number.
It wasn't long until an enterprising young scientist, Edward Teller, capitalized on this. He created a monster, something that had never been seen before. It stood at a massive 2 stories tall. But inside, it was divided into 2 compartments. The bottom contained separated hydrogen isotopes, tritium and deuterium, kept at supercool temperatures, while the top contained a standard Nagasaki-style atomic bomb just to get the reaction going. The U.S. military tested this device on a lone Bikini Atoll, unsure of what they would see. The detonating atomic bomb released energy waves, powerful enough to superheat the hydrogen isotopes and compress them to the point where the isotopes fused and released enormous amounts of raw energy into the atmosphere. The U.S. military was impressed, with good reason, for the bomb weighed in at 10 megatons of TNT. The bomb itself was weaponized into the Mark 17 thermonuclear bomb, weighing in at 25 megatons of TNT and carryable by the B-36 bomber. Like before the H-bomb test, this is what remains of it after the explosion. The H-bomb's true power was immediately recognized, and it was proven to be 10 times more effective than the traditional atomic bomb. During the Cold War, bomb fever immediately spread and led to the creation of such documents as this, the St. Louis H-bomb escape plan. And the panic was not unjustified, for the Soviets quickly developed their own hydrogen bomb project that would eventually go on to surpass the Americans. The Soviets would go on to leave their own mark on history with the Tsar Bomba, the world's largest hydrogen bomb, weighing in at 50 megatons, and this only after halving the original size. However, fusion has been shown to have a much more positive connotation for humanity. It has been proven to be a source of power. Central plasma is made up of negatively charged electrons and positively charged atomic nuclei. It is feasible to keep said plasma stabilized in a ring shape by magnetic fields and heated to conditions where fusion can occur. A device capable of doing this would need to be carefully engineered and capable of dealing with truly intense conditions. In addition, a large amount of power is necessary to begin the reaction. After all, it is an atomic bomb that is needed to initiate fusion in a hydrogen bomb. An exterior power collecting wall and an interior fusion chamber would be required for such a device. Inside the chamber itself, the reaction would not only keep itself going, but would also release 80% of its energy in neutrons given off during the fusion process. These neutrons, being neutral, would not be influenced by the chamber's magnetic field, and could thus be collected in the chamber walls as heat. This heat can be converted to electrical energy and would provide us with the most useful power. For this video, however, we're going to leave you without a miniaturized